Good day, everybody. Here we go. We're going to talk today about something that's fairly new to grade 7s, and that's the topic of square numbers and square roots and how they're related to each other. So to get an idea of what square numbers are, it's important for us to have an idea and use a multiplication chart to help us understand what square numbers are. Basically, a square number is any number you get when you multiply something by itself. So for example, if I take 1 and multiply it by 1, the answer is 1. So a square number, or the first square number, is the number 1. Because 1 times 1 is 1. And remember, squaring a number means multiply a number by itself. So if I square the number 2, 2 times 2, that's 4. Okay. Not a really challenging idea, but it's something that we have trouble with understanding in grade 7. So 2 times 2, there we go, it's 4. If I square the number 3, 3 times itself, 3 times 3, there we go, that's 9. Okay, so I can keep going, and as you can see in this multiplication chart, I can see a pattern as to where the square numbers are sitting. They go straight through the diagonal here. 4 squared, 4 times 4, 16. 5 squared would be 5 times 5, 25. 6 squared is 36, so I can keep going. 7 squared is 49. 8 squared, 64. 9 squared is 81. 10 squared is 100. 11 squared, 121. 12 squared is 144. So a number multiplied by itself, that's squaring a number. These highlighted numbers down the diagonal here are called perfect square numbers. So these highlighted ones are called perfect squares. We call them perfect squares for a pretty simple reason. I'm just going to get rid of this here for a second, make it a little easier to see. Just highlight those again. Perfect square numbers are called that because they form a perfect square. So let's look at 2 squared, for example. A 2 by 2 square has an area of 4. And so that makes a perfect square right there. There is a, well, my tracing stinks, but a 2 by 2 square makes an area of 4, and it's a perfect square. A 3 by 3 square, at the same time, here we go, 3 down this side, 3 across, so it's a perfect square as well, 3 by 3, and it has 9 squares inside, an area of 9. So these perfect squares are actually numbers that can be arranged. If you had that number of tiles, for example, or cubes, you could make a perfect square. So for example, a 6 by 6 square has 6 long and 6 wide, so there are 36 squares on the inside of that. So they make an actual shape of a square. They can be arranged into a square. So that's where the number comes from, or the name comes from, sorry. So what I want to remember are a few things. When I write squared numbers, for example, 3 squared, I write it as an exponent like this. A base number and an exponent. This tells me what is 3 squared. This is what this says. And if you watch the video, or if you're going to watch the video about how we do exponents, this means I'm going to take the 3 and multiply it by itself. So there are 2 3's being multiplied. 3 squared is 9, just like we said here. 8 squared. Well, that's 8 times 8. And if we look into the grid here, 8 times 8 is 64. If we know our multiplication facts, hopefully we do in grade 7, 8 squared is 64. Okay. What I want you to do is tell me what are the next 3 square numbers. So 12 squared is 144. What would 13 squared be? Or 14 squared? Or 15 squared? I could go across here with 13, 14, 15, but I'm out of space. So what would those numbers be? How would they fit? along my diagonal. Just pause the video for a second. Tell me what the next 3 square numbers are. All right, either you pause it or you didn't pause it and you're just waiting to see, but 13 squared, that means I'm taking 13 and multiplying it by itself, and that is 169. So the next square number in the pattern would be 169. 14 squared, 14 times 14, and that is 196. 15 squared would be 15 times 15, and that is 225. And the square numbers, the perfect square numbers, go on forever. You can square decimal numbers, you can square negative numbers, but we're going to just focus on squaring positive whole numbers in grade 7. One other thing that I want to point out here, I'm just going to make a little bit more space, so I'm going to take and get rid of this, is have a look at how these numbers change. So I'm going to write down the first 3 or 4 square numbers. So the first one is 1. The second square number is 4. The third square number is 9. Fourth square number is 16, and so on. When we get into our patterning unit, we're going to be checking out patterns that change like this. So let's look at how these numbers change. To get from 1 to 4, we're adding 3. To get from 4 to 9, we add 5. To get from 9 to 16, we add 7. There's a pattern in how the square numbers change. It goes up by 3, then 5, then 7. So the next one's probably going to go up by 9. So we're going up by 2 more every time. If I add 9 onto 16, that's 25. 25 is the next square number. So this pattern in how square numbers change is really important. It's something that's going to be important for us to recognize when we get into working with patterns of square numbers. But that's a little later on. But what's important for us to try to remember is what are the basic square numbers? 1, 4, 9, 16, 25, and so on. Okay, and we're going to be working with these a lot this year. Also, this gets a little intro into what exponents are, which we're also going to be doing very shortly. The last thing I want to talk about are square roots. Okay, square root is the opposite of squaring. It's like multiplication is the opposite of division, and division is the opposite of multiplication. Square root is the opposite of squaring. So if I see a symbol that looks like this, this is your square root symbol. And there's going to be a number underneath here, which is what I want to find the square root of. So let's try 9, because that's easy. And we already have the answer really up here. Square root of 9 means what number can I multiply by itself and give me 9? Well, if I look up here, I multiplied 3 by itself and got 9. Or I squared 3 to get 9. So the square root of 9 is 3. If you think about this, I can rewrite this like this if I want to. 9, whoops, that's not right. That should be 3. 9 is the same as 3 times 3. So the square root of 9 is just what number did I multiply by itself to get 9. So the square root of 9 is 3. Going the other way around, 3 squared is 9. So squaring and square rooting are the opposite to each other. Okay. There are other things I can do to multiply and get 9. I could do 9 times 1, but that's not multiplying the same number by itself. Okay. So square rooting is simply finding a number that multiplies by itself and gives me the value underneath the square root sign. So as an example, what would be the square root of 81? So you're looking at this, before you grab your calculator and figure out how to use the square root button, you have to think to yourself, what number can I multiply by itself? And the answer is 81. Well, let's look through here. Where's 81? There it is. What number did I times by itself to get me this 81? Well, 9 times 9. So the square root of 81 is 9, because when I multiply 9 by itself, the answer is 81. Or when I square 9, the answer is 81. Okay, so we're going to be doing a lot of this and trying to understand fully what this idea of squaring and square rooting is. Okay, hopefully this video was helpful for you. Go back over it if you need to. Come see me with any questions. But that's a good intro into what squares and square roots are.